Let's consider the next question, that is question number 19. Alpha beta be the roots of the quadratic equation. One quadratic is given. Theta is between 0 to 45 degree and alpha is less than beta. Then we have to talk about infinite series summations like alpha n and minus 1 by beta whole to the power n. So we have to talk about some of these two infinite series. So for that purpose, let's first find the roots of this quadratic. If you rearrange this quadratic, you can see, let's rewrite this quadratic equation. This can be written as x square sine theta. Now when you distribute this x, you get x sine theta cos theta minus x plus cos theta is equal to 0. Now first two terms you can take x sine theta common. So this gives you x sine theta. From the next two terms you can take minus 1 common. You observe x minus cos theta as the other factor. So the roots are finally x equals cos theta and the other is x equals 1 by sine theta, or you can say cosec theta. Theta is between 0 to 45 degree, alpha is less than beta. So clearly now you have this root as alpha and this root as beta. This is clear. Now we are looking for alpha to the power n. Therefore, summation alpha to the power n, where n is 0 to infinity, that becomes infinite series as 1 plus cos theta plus cos square theta and so on, and the sum of this infinite series is 1 upon 1 minus cos theta. Right. Next, you need summation n from 0 to infinity minus 1 by beta whole to the power n. This gives you 1 upon 1 plus sine theta. Because when you put here beta as 1 by sine theta, so 1 upon beta is simply sine theta. So that gives you the second sum. Now final question is sum of the two. So add the two to get the final result, 1 upon 1 minus cos theta plus 1 upon 1 plus sine theta, here as option number 2. So I am sure this question is clear how we get the final result for it. Let's move on to the next one. A bag contains 30 white and 10 red balls. 16 balls are drawn one by one randomly from the bag with replacement. If x the number of white balls drawn, then mean of x divided by standard deviation of x is. Now what is the mean actually we define? We define as NP, and standard deviation we have variance as NPQ. So standard deviation is root NPQ. So the required result is actually required value is NP divided by root of NPQ. That is, we are looking for square root of NP by Q. Now what is N? N given to me is 16, right, as 16 balls are being drawn. Now a bag contains 30 white. So what is the probability of getting a white ball in one draw? It is simply 30 by 40 because ball has been replaced. So we have P equals 30 by 40 or simply 3 by 4. So Q is 1 by 4. Correct. We have the complete data, just substitute the value to get the result as square root of 16 multiplied with 3 by 4 divided by 1 by 4 is equal to 4 root 3. So the correct answer for this question is 4 root 3, which is available here as option number 2. So let's mark and write it as the answer. So I am sure this question is clear. Let's move on to the next question of this paper, that is 21st. If a hyperbola has length of its conjugate axis equal to 5, conjugate axis, let's say this is 2b, and the distance between its foci is 13, that is twice AE, then we have to talk about eccentricity. So let's start it. 2b, that is length of conjugate axis, is 5. 2AE is equal to 13, right. Now we need eccentricity. correct? We have one relation as b square is equal to a square e square minus 1. If I use this relation, I can write here simply 25 by 4 is equal to AE is 13 by 2. So, we have 169 by 4 minus a square. From here we get a square equals simply 169 minus 25 whole divided by 4, that is a square is 144 by 4. This point is clear. So, from here we have the value for a as 6. Once we get a, substitute it here to get the value for e. So, here we have therefore E equals 13 by 12. So, the correct answer, the required eccentricity is 13 by 12, that is option number 4. So, I am sure this question is clear. The correct answer is 4. Let us move on to the next question of this paper, that is 22nd.